All right, this is 3-4B. There's no warm-up, so you don't need to worry about it. We are doing permutations and combinations today. Permutations, we kind of touched on last section. That's when you are putting things together and the order matters. In a combination, the order doesn't matter. So you could just pick them in any random order and you're good to go. So there are a couple different formulas we're going to have to learn and know which ones to use when. So the permutation of n objects taken r at a time. Okay? So what that means is that you have, like, let's say we have 15 kids in class and I want to pick them. I need to pick 3 of them to go down to the office. Okay? So I have 15 kids in class and 3 of them are going to the office. That is n kids and r ones that are being picked. Okay, so 15 kids being picked 3 at a time. So n is how many total you have, and r is how many you're picking from that. And the order matters in a permutation. Permutation, order matters. Okay? So let's say I'm going to send those kids down to the office. The first one is going to get a detention, the second one is going to get a piece of candy, and the third one is going to get to go out to lunch. Okay? So it matters if you go first. If you go first, you have to get a detention. If you go second, you get a piece of candy. If you go third, you get to go out to lunch. Okay? So those are different things. So the order matters, who I pick, who I send first, second, and third. Okay? So this says the number way of forming a 3-digit code when no digit is repeated. Codes, the order matters, right? So you can't put a code in any which way and have it work. So we have 10 digits. We established that before, 0 through 9. Whenever you see the word digit, there's going to be 10 of them. Since it's a code, the order matters, and we're picking 3 of them. Okay, so n choose r n factorial over n minus r factorial. Okay, that's our formula. So our n is always our bigger number. We've got 10 digits to choose from, factorial, over 10 minus 3 factorial. This one's simple in the fact that you can easily do that subtraction. So you just have 10 factorial divided by 7 factorial, and I would do that subtraction and then just do that in your calculator. So all at one time, don't find each thing separately. So do 10 factorial divided by, don't use ABC, 7 factorial, and you got 720. So there are 720 ways to make that code. Okay? Distinguishable are the categories, like you have different categories of things. These will say the word distinguishable. So you know you need to use this one if it says the word distinguishable. So there are different categories, like we're going to do one with trees. So you've got different types of trees. So the top number is how many total things you have, and then the bottom number are all of the different categories. So this is your total, and then these are all of your categories. Okay, so how many, if you've got 3 categories, then you would stop after 3. If you have 12, then you would keep going. So however many things you have down at the bottom are how many different categories you have. So a contractor is planning to develop a subdivision that consists of 6 one-story houses, 6 one-story, 4 two-story, and 2 split level. How many ways can these houses be arranged? So you have the different categories. Total, 6 plus 4 plus 2 is 12 total houses. So 12 factorial is on the top. Okay, 6 plus 4 plus 2 is 12. On the bottom, we have each of the categories. So I have 6 factorial, a 4 factorial, and a 2 factorial, because that's how many of each one you have. When you put this in your calculator, you can do it all at once, but you have to be careful. These bottom ones all have to go in the same set of parentheses so that it doesn't divide and then multiply. So you're going to do 12 factorial divided by parentheses. 6 factorial, 4 factorial. You don't have to put anything in between. It knows to multiply them. And then 2 factorial. Close parentheses. Enter. And you should get 13,860 different ways. Combinations, order doesn't matter. And that is the difference, okay? So when the order does not matter, so if I need to pick 3 kids to go to the office and all 3 kids are going to get to go out to lunch, it doesn't matter who I send first, who I send second, who I send third, okay? It has an additional r factorial on the bottom because that's going to be fewer ways to send 3 people to the office if the order doesn't make a difference. Okay, so you have to divide by a bigger number to give yourself a smaller answer because there are not as many ways to do that. So, the Department of Transportation plans to develop a new section of highway that receives 16 bids, okay, for the project. They plan to hire 4 of the bidding companies. How many different combinations of 4 companies can be selected from 16? All 4 companies that get picked are going to do the same job, so it doesn't matter who they pick first, who they pick second, who they pick third. So the order doesn't matter. So when the order doesn't matter, you have n factorial over n minus r factorial, and then another r factorial. Okay? N is how many total we have. We have 16 companies. R is how many you're picking. So we have 16 total minus 4 that I'm going to pick, and then another 4 factorial because the order doesn't matter. I would still suggest you do the subtraction first. So 16 minus 4 is 12, and then you have another 4 factorial still. Now, this is going to be put into your calculator similar to the distinguishable. You need to put the parentheses around the bottom. So 16 factorial divided by parentheses, 12 factorial, 4 factorial. Close parentheses, enter 1,820. There are a lot fewer ways to do things if the order doesn't make a difference than there are if the order does make a difference. Okay? All right, that's 3-4B.